So continuing this part of Lightning Talks, where we talk about Apache Software Foundation projects, is Alexander Bezubov, who will be talking about visualization of big data.
And test it. Just
hey. Can you hear? Okay. So I think it's a bit different from what Roman has announced. So I used to work on visualization for big data, but this particular talk is about tools for large-scale collection and analysis of source code repositories. And that's something I've been working on in the last half year, and that's exciting, even maybe more exciting than visualization part. So my name is Alex, and well, I'm engineer at Sourced and also a committer and PMC at Apache Zeppelin. Sourced is a startup in Madrid that I joined recently. It's very cool, and all the things that we work on there are open source. So, and I'm going to talk about some tools that I built and my colleagues built during the daytime job. So, well, we collect a lot of source code, but why? And so it's twofold. One, it's the research material for academia, and two, it's the fuel for data-driven products on top of the source code. And it's kind of rapidly evolving area of building better tooling to write programs, so it's quite exciting. But first, you need to get the data, and that's what I'm going to talk about. It's open source pipeline that you can use on premises to collect a lot of Git repositories, because, well, it's the most popular version control system, and that's the source of truth about source code. And the collection pipeline is pretty standard, like we've got a crawler, a distributed storage, and a parallel processing. So after you store that, most probably you want to go through that and figure something out. So we'll briefly go through the tech stack, and what the takeaway of this talk is that if you're interested in large-scale data collection, there are awesome existing open source tools, and there are some new ones that I wanted to share today. So things that have black, well, gray boxes around are the things that we build at Source. But we're going to go through all the stack one by one, and to run the software, well, you need some hardware. And on infrastructure side, we have a dedicated cluster which is, I think, kind of called the immutable infrastructure these days. So there's basically machines that are from boot provisioned with CoreOS, and they eventually become a part of a Kubernetes cluster where you can schedule your application on. So it's very nice and automated. There's going to be detailed talk about that in configuration management camp on Tuesday in Ghent, if somebody up for learning more details about the infrastructure part. On the collection part, so, well, we've got machines, we want to get some Git repositories. So it consists of two parts, getting the URLs to that repositories and then basically cloning them. And, well, we focus on Git, and that's the most popular thing, so you need to talk Git language to be able to do that. We implemented custom implementation of the Git protocol format and storage format called GoGit, and there was a talk about it last year. It's in Go language dev room. It's a pure Go implementation, one of the big 5 implementation of Git. It's very extensible and it's interesting. You can do a lot of things like store things in memory when you want to, or add custom protocols, or store things in database if you want to. So that's something we use for cloning part. And then there are 2 separate programs. One is to find the URLs of the Git repositories and store them in database, and second one to schedule their cloning. This is called rovers and Borges parts, and well, there's hundreds of millions Git repositories, so we want to be space efficient, and there's some nice tricks you can do, like store forks together in a single Git repository, because you have an extensible Git library. And that's the concept of rooted repositories depicted in the middle. So basically, repositories that store history and start with the initial commit to the same hash, get stored in the single big repository, which works really nice. So, well, you collected URLs and you collected Git repositories, most probably want to store that somewhere, and it's got to be distributed. So on URL part is just a Postgres database. We wrote custom ORM implementation in Go, which is type safe and quite nice, called Calyx. And for repository side is HDFS, which works very well, but it scales linearly with a number of files in it, so you want to minimize number of files. basically how we do it with custom archive format implementation. So every rooted repository end up being in a single file inside database. This is an example of custom archive implementation called Siva. It's seekable, appendable, and indexed format. So it's block-based, and this way you can fetch repository once and then append it after new clones or fetches happen. And it's all stored in HDFS. So after it gets stored, you want to process it somehow, and Apache Spark is a good way to do batch processing, and on a cluster of machines, Spark SQL is something useful people understand and know how to do. And we built custom library to expose those Git repositories to the Spark API level. It's called Engine, and it exposes references, commits, files, and so on in Spark language. Be that Python or Scala, which is super nice. And it talks through gRPC interfaces to more advanced stages of analysis of the source code if you want to do that. Here's an example of usage of that library. I'm not sure if you can see that. You can extract with a simple pipeline like that. You express the extraction of references, taking the head reference and then getting all the files, and for every file, do something like detect the language and so on, which is quite concise and really great that both engineers and machine learning people can use that, because there is Python and Scala APIs for that. And after just iterating through files, most probably you want to do some more advanced stuff. And there are two projects on this side that we have built. One is Henry, which is a programming language detector. It's kind of rewrite parts of the GitHub linguist is the thing in Ruby that GitHub uses. It shows you the distribution of languages on top of your repositories. One that we use is in Go and is compatible with the linguist and is faster. Basically it's from 4 to 20 times faster on our measurements than original Ruby one. And another one is Project Babelfish, which is a bit different because, first it's scalable parser infrastructure. So it wraps native parsers inside containers that you can schedule across the cluster, and that exposes uniform gRPC API. So that way you can extract a lot of information from the source code in very uniform fashion. And it has drivers for many different languages and something called universal abstract syntax tree, which is native syntax tree of the language annotated with some language independent things that we might be interested in on the later analysis stages. And that's a high-level overview, and there are some future things that we want to get done. For example, on Kubernetes side, having bare metal cluster and persisting storage is not really easy thing to make. On the collection side, there's a concept of stage event-driven architectures. It's a paper published by Google, I think, about how to make a scalable system that dynamically saturates some resources by having queues in between the stages, which is very interesting if you want to do, clone 100 million of repositories. On the processing side, we're looking into adding distributed indexes to speed up Apache Spark queries that we have. And on analysis part, there are advanced things like how do you def abstract syntax tree, or how do you extract cross-language information from abstract syntax tree, which we're looking at in a Babelfish project. That's it.
Any questions? All right.
I was wondering if you're also looking at the readmes when you pull from the repositories, because I think GitHub does a very bad job at figuring out which language is the one of focus.
Yeah, so that's, the question was, do we look at the readmes? So the thing is, the collection pipeline I described is generic, so you get everything. You get full repositories. On the project that detect language, this does not do anything except what GitHub is already doing, so it's also doing the same job. But there is some research in that area which is quite cool, which comes from natural language processing and machine learning area. Well, how do you tell which language is that? Like basically classify language based on the source code. And you get pretty good results. It's not inside Henry first, it's more yet, but it's more in the research stage, and I think it has a lot of potential. Hopefully even to be able to merge upstream in GitHub implementation, so it does a better job But yeah, that's a good one.
Any other questions? Okay, thank you so much.